to talk today about segments and angles. We talked about how to name them the other day. Now we're going to talk about how they can be measured. And all right, so this is the second part of lesson 1, actually. Okay, so if we look at this first example here, how can you find the length of C and D? Well, we have a number line, and we have points on the number line, right? And I want to find out what the length is between C and D. So this is really a pretty simple problem, right? You can almost just count it with your finger, right? 1, 2, 3, correct? Okay, and so the answer for that length would be 3. And our first postulate is called the ruler postulate. Now, a postulate is basically a rule in geometry that's accepted true without proof. It's kind of common sense. And the ruler postulate says that every point on the line can be paired with a unique real number. This number is called a coordinate of the point. Okay, so we have x and y, and the coordinate of x is 3, and the coordinate of y is 7. And this statement said that each point can be paired only with one specific number. Okay, because x can represent 3 and 3.5 at the same time, because that would change the length of the segment. Okay, so kind of weird, kind of common sense, like I said. And so when you go to find the distance between any 2 points on a line, it's basically the absolute value of the difference between their coordinates. And so up here it was really easy because all you had to do was count. But what if the numbers were 2 and 1 8 and 5 and 4 6? All right, you couldn't just count. All right, you would actually have to do a little math. And so you take and subtract the absolute value. So if this right here is at 3 and this is at 7, they show you that to find the length between x, y, you would subtract those coordinates and take the absolute value. And I could do it in either order. So I could do 7 minus 3, which is positive 4, or 3 minus 7 and take the absolute value of that, which is also going to be a positive 4. Okay? So you need to understand that, really to find the length on a segment, you subtract to take the absolute value. Now, notice that they have the 2 letters with nothing on top of them. The other day we talked about how do you name a line, how you name a segment, and array, and the stuff has to go on top, right? But when there's nothing on top, that represents the length of that segment. That's how long it is, okay? So always make sure that you denote things like you're supposed to. All right, so use the ruler postulate to find the coordinates of K and L. A postulate is a statement that is assumed to be true, right? Okay, so I told you that a while ago. Okay, so K is coordinated with 12. Its coordinate is 12. L's coordinate is 16. So if I wanted to find the length of it, what did I say to do? Subtract and take the absolute value. And the order doesn't matter, so I could do 12 minus 16, and that is the absolute value of negative 4, which is 4. Okay, so our next postulate, again, kind of a common sense thing, it's called the segment addition postulate. The segment addition postulate states that if points A, B, and C are on the same line, what's another word for being on the same line? Collinear. If A, B, and C are collinear with B between A and C, then AB plus BC equals AC. Now, if it says that one point is between 2 others, then that means it has to be somewhere in between, not necessarily right in the middle. It just has to be in between those 2 points somewhere. Okay? And so if you have 3 points that are on the same line and 1 point is between the 2 others, then I can take the length of that first part plus the length of the second part, and it's equal to the entire segment, which kind of makes sense, right? It's like the whole is equal to the sum of its parts. Okay, so this first part plus the second part equals the whole thing. Now, I'm going to show you this. Okay, so notice in this problem, B is between A and C, right? It's actually right in the middle because AB is 5, BC is 5, and AC is 10. But what if I moved it? And I moved it here it's still in between. This now is 6, this is 4, but the whole thing is still 10. Okay? So it allows, that segment addition postulate basically is just saying that you can take the first part of the second plus the second part of the second segment and it equals the whole segment. Okay? Okay. So with that in mind, it says that points F, G, and H are collinear. It says that GH is 16, and we want to find FH. Okay? So, we want to find this entire segment first. Okay? And in order to find that entire segment, what do I need to find out? I know that this right here is 16, right? And this is 3x minus 1. There's not going to be any way for me to find the entire thing unless I know what? X, right? I need to find x. And in order to find x, I have to have an equation. Okay? An equation is two things that are the same, that equal to each other, right? Sometimes it's two things added together equal to a third part, okay? But an equation says that this side is equal to that side. Do I have anything here that's equal to each other? The 16 and the x plus 2 represent the same segment, don't they? Okay? These two, the 16 and 2x plus 2, represent the same segment. So I can set 2x plus 2 equal to 16. And so I'm going to subtract 2 from both sides. And then divide both sides by 2. And x is equal to 7. Okay? And so that's 7. Now I'm wanting FH, which is the entire thing. I already know that this is 16, right? We put your probably. I already know that this is 16, so if I can figure out what this part is, then I can find the entire segment. So if x is 7, I can plug it in here. Okay? So that's going to be 3 times 7 minus 1. That's 21 minus 1, which makes this right here 20. Okay? And so we learned a few minutes ago that if I have a whole segment, I can add the two pieces together and it equals a whole. So I can do 20 plus 16 equals 36. Now, as you can tell, this was not drawn to scale, right? Okay? And that's going to be true in geometry. You can't always go by what it looks like, okay? So keep that in mind. All right, I added a problem. Okay, I added a problem, so let's do this one together. Now, many times, it gives you a description. Okay, it's not on your paper, I added it, so just put it at the bottom. Okay? It gives you a description. So if it gives you a description, you have to draw a picture and label it. That's huge. Okay? So draw a picture and label it. It says that y is between x and z. What does that tell me? Y is between x and z. What do I get from that? Y is somewhere in the middle, right? All 3 points are collinear. Y is somewhere in the middle, right? Okay. Then I have to label. It says that xy is 2x minus 1. YZ is 3x plus 12. And xz is 15x minus 19. So, I drew a picture, I labeled it. Okay? Now, I'm trying to find the length of x6, so I want the whole segment. But before I can find the whole segment, what do I have to find? X. And in order to find x, I have to set up an equation. And in order to have an equation, I need two things that are equal to each other, correct? Okay, so what am I going to do? What can I do to solve for x? Okay, so we're going to add these together and set it equal to the whole thing, right? Yes? Okay, so I've got 2x minus 1 plus 3x plus 12 equals 15x minus 19. Alright, so I got to collect my like terms here. 5x plus 11 equals 15x minus 19. Okay, I'm going to bring my 5x over. and I'm going to add 19 to both sides. Okay, and I get 30 equals 10x. I'm going to divide both sides by 10, and I get x is 3. Am I done? No, be careful, okay? Sometimes it asks for x, but what is it asking for? xz, right? It's asking for this entire segment, okay? So, to find xz, we know that it is 15x minus 19, and I found the variable x to be 3. So that's 15 times 3 minus 19. That's 45 minus 19. That's 45 minus 19. 26? Taking your word for it, 26. So that length is, for xz is 26. Now, everybody knows that this x here represents a variable is different than that x. Everybody understand that? Okay, I didn't think about that. X is gone. All right, questions on that? Okay, let's go to the back. Kind of the same idea. Now we're going to work with angles. Okay? We have a protractor postulate. It says that given ray BA, okay, here is ray BA. Mark, I have something for you when I get done with this lesson, so don't forget. So I have ray BA, and I have point C not on that ray. It says a unique real number from 0 to 180 can be assigned to ray BC. So 0 is assigned to BA, and 180 is assigned to BBD. Basically, just like the ruler postulate, okay, these are unique. What you assign to this is going to be unique, okay? This angle can't represent 2 different degrees. Even though there's 2 different numbers, okay, it only represents, in this case, 60 degrees, all right? Because this is 0, and as it gets getting bigger in this case, this is going to be a 60-degree angle, okay? So if I look at this next problem, it says, what is the measure of BEC? All right. Well, I need to look and figure out like what this angle measure is. This looks like it's sitting at about there's 45, 47. Okay, so this line, this point right here is 40. So this angle is 47. Okay. This one looks to be sitting at 0, there's 90, 105. That's sitting at 105. I am wanting that little angle right there. What do you think I'm going to have to do? I'm going to have to subtract and take the absolute value. So the absolute value is 105 minus 47. What's that? What? 58? So it works kind of like this, you know, the ruler. Okay, so we have the segment addition postulate. Now we're going to have an angle addition postulate, which is exactly the same idea. Okay? And this one states, if D is in the interior of angle ABC, then the measure of angle ABC plus the measure of angle DBC equals the measure of angle ABC. Okay, so that's kind of wordy. So we have D right here, and it's in the interior of angle ABC. So this is ABC, and D is in the interior. You can draw a ray from the vertex to that point. And what it's saying is that if I add ABD, this angle right here, and I add this little angle right here, it's going to be equal to the entire angle. Just like the segment addition postulate, but it's with angles. Okay? And I can do the same fancy stuff that I did with the segment. Okay, so look at this angle right here. See the blue? See how it tells me that this whole angle is 60, right? This C right here is right through the middle. This is 30, this is 30, so 30 plus 30 is 60, correct? But let's say it was in a little bit different location, okay? Let's say it was here, This is now 23. This is now 57, but they still add together to equal 60, correct? So if you have a ray inside an interior, inside the interior of your angle, you can take one part plus the other part, it equals the whole, just like with the segment, okay? All right, so let's look at this problem. It gives us a description. It says that D is in the interior of angle ABC. So I have to draw a picture. A, B, C. It says that D is in the interior, and you can draw a ray, so it creates two angles. Okay? Then it gives us information. Okay? It tells us that ABD is 3x plus 6. So this is 3x plus 6 right here. Okay? Then it tells me that DBC is x plus 2. That angle is x plus 2. Then it tells me that the big angle, this whole angle ABC, is 2x plus 18. Now, I will tell you, I did change the numbers from your sheet. Now, sorry about that. I made this a plus, it was a minus, and I added a 1 right here. It didn't work out right earlier, so I had to fix it, okay? Alright, so this piece is 3x plus 6. This part is x plus 2. The whole thing is 2x plus 18. And I am trying to find the measure of the whole angle ABC, okay? And you might want to circle what it is you're trying to find so that you don't make a mistake. Okay, so what am I going to have to find before I can find the measure of angle ABC? X. And in order to find x, I have to set up an equation. Okay, what's my equation going to look like? 3x plus 6 plus x plus 2 equals 2x plus 18, right? So one part plus the other part equals the whole. Alright, so now I've got 4x plus 8 equals 2x plus 18. And I'm going to subtract 2x from both sides. I'm going to subtract 8 from both sides. So that gives me 2x equals 10. And then divide both sides by 2, which makes it 5. Okay? Alright, so is that my answer? No, I need ABC. So I've got to come back over here and find the measure of angle ABC, which is 2x plus 18. And I know that x is 5, so I plug it in, and that gives me 10 plus 18. So the measure of angle ABC is 28 degrees. Alright, so it's just like with the segment. Segment's name. Okay? Alright, now congruent and segments and angles. The word congruent means the same as. And in order for something to be congruent, it has to have the same measure. So it says segments that have the same length or the same measure, okay, are considered congruent. And this is the symbol that we use for congruent. It's a squiggle with an equal sign underneath. Okay? It's a lot like equals, but if you say that AB equals CD, that tells me that the length of AB is the same length as CD. But if I use the congruence, and notice how it's got segments over the top, you're identifying, you're saying this segment is the same as that one. This one talks about the measure, this one talks about the segment. They're interchangeable. You can go from one to the other. Because for this to be true, that has to be true. Okay? And for this to be true, that has to be true. Okay? And so if you're told that two things are congruent, they use these little tick marks to indicate that. So I know that AB and CD are the same, which means they have the same measure. And I know that PQ and RS are the same, and that they have the same measure. Now, they used 1 here and 2 here, because if they used 1 on all of them, that would tell me that all 4 of them were the same. Okay? So you have to distinguish. Okay? Alright. The same thing with angles that use just arcs instead of ticks. Okay? So you've got to have a double arc here and a double arc there. Okay? Alright. mention is that when they're using the little m in front, that's talking about the measure of it. When there's not an m in front, they're identifying the angle. Okay, so the m represents the measure, and without the m, it represents just the angle itself. Okay, so let's look at this example, last one. It says, if XWZ is this whole angle, is 127. Okay, what is the measure of YWB? I always have to read it carefully. For some reason, I'm dyslexic when I read angles. They all move around all the time. It moves around on me. So YWV is what we're looking for. Okay, that's my unknown. Okay, right there. What do these little arcs tell me? They're the same. So if this is 32, then what's this? This one's 32. Okay, so what am I going to do to find that missing piece? Yes. 32 plus 32 is 64. Okay, so 64 plus what I'm looking for equals 127. Right? So 32 and 32 is 64 plus the missing piece is equal to 127. So then what do I do? Subtract 64. And I get 63 degrees. All right, any questions?